Kia ora, and welcome to a lesson on Cambridge Mathematics P3 Introduction to Complex Numbers. So today we are going to look at what is a complex number, how do you get a complex number, and how can you combine complex numbers together to get a different solution. So the first thing to address is what is a complex number. So a complex number is a number made from a real part and an imaginary part. And it's a two-dimensional number, basically. Our numbers generally are one-dimensional, but this is a two-dimensional number. So when you think of numbers, you've got your standard counting numbers. So your 1, 2, 3, 4, your whole numbers. You've got your negative numbers as well. So -3, -2, -1, 0, 1, 2, 3. They're your integers because they're whole numbers that include negatives. So we've got counting, we've got integers. You've got rational numbers, so that includes your fractional values. Okay, and decimals such as 0.6 and because 0.6 can be represented as a fraction. A rational number is any number that can be represented as A over B. And then you've got your irrational numbers, such as your √2s and your pi's and your e's. But these are all numbers that we can write down. Pi is 3.141592, blah, 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 blah. √2 is 1.4 something, something, something. So they're still numbers that exist in our normal understanding of numbers. So what is an imaginary number? Okay. And even though it's called imaginary, it's something that makes kind of sense, which is to do with kind of like your irrational number stuff. What you've been taught before is that you cannot do root of a negative number, okay? There are no two numbers which times together, so there's no number that times itself would give a negative solution, because you've got negatives times negatives are positives, positives times positives are positives, and nothing times itself can produce a negative. So we created imaginary numbers to satisfy that gap in our mathematics. So what we actually say is that a number, I, times by itself gives a negative solution, which when rearranged, you can say that I is the square root of -1, okay, in its basic, plus or minus. So that's it in its basic form. Okay, generally we just refer to the positive, so we just tend to refer to it as I is equal to root -1 in most of our cases. Yeah, so there we go. Imaginary numbers, I is root -1. So now we need to be able to use this with some other numbers. So if I is the root of -1, what is the root of -9? Well, to find the root of -9, what you need to do is split it into two parts. Basically, you can say that root -9 is the same as √9 times -1, which can be split through third law to √9 times root -1. And it's not something I don't think we've covered in P1, 2, or 3, but surds have the ability to split a root of a value down into multiple parts so that you can simplify. But root -9 can be split into √9 times root -1, which is just 3i, because √9 is 3, root -1 is I. Let's have a look at another example. what about root minus 5? Well, root minus 5 can be split up into root 5 times root minus 1. Root 5 is just root 5, so you just say that is I root 5. Okay? And let's have a look at another one, root minus 18. So example 3, root minus 18. Where root minus 18 can be split up into root 18 times root minus 1. Root 18 can actually also be split up into root 9 times root 2. And whenever you're dealing with surds like this, you're always wanting to split it into something that's a square. So when I look at root 18, I go, what square number can I divide 18 by? Well, that's 9. If there is no square number I can divide 18 by, then root 18 can just stay as root 18. But in this case, root 18 can become root 9. So this just becomes 3i root 2. Or 3 root 2i. However you'd like to write it. Probably 3 root 2i is probably the better way of writing it. So 3 root 2 all times I. Okay. Well, that's that. What about some calculations using I? So let's have a look at another example. What would 3i squared times 3i all squared equal? So you got to think about this, what the squaring is doing. So in the first bracket, the squaring is only on the I. So we've got to think, what is I squared? Well, as I said earlier on, I squared is minus 1. So this just becomes minus 1 times 3, which is minus 3, times by 3i all squared, which would be the same as 9i squared. Well, I squared, again, is minus 1. So this would become minus 3 times minus 9, which is positive 27. Oh, sorry, so no, that would be positive 27. There we go. That is the answer to that question. Let's have a look at another example. Example 5. Minus 8i plus minus 4i cubed. Let's have a look at what's going on here. Well, minus 8i, there's nothing I can currently do with minus 8i. So let's have a look at the plus minus 4i cubed. Well, when I expand out that bracket, I get minus 4 cubed, which is negative 64. And then I cubed. And you've got to think, what can you do with I cubed? Well, I know that I squared is minus 1. So what is I cubed? Well, I cubed is I squared times I. So I cubed just becomes minus I. So when I put minus I back into here, that changes the minus 64 to positive 64. And then just I. And then minus 8i plus 64i is 56i. So that's how you can deal with that question. So knowing what I becomes with different powers is all about thinking about the I squared being minus 1, and then thinking about the minus 1s times the minus 1s, which we'll see in another question in a second. Let's have a look at another example. 6. We've got root 9i plus 16i over 4i. Well, 9i plus 16i is 25i. So this becomes root 25i over 4i. Well, I divided by I will cancel out like any other. So this just becomes root 25 over 4, which is the same as just 5 over 2. Example 7. What is I to the minus 6? Well, minus means make it 1 over, so this is 1 over I to the power 6. What is I to the power 6? So this is what I was on about breaking I down. So I can say that I to the 6 is the same as I squared times I, well, I can just do it as I squared cubed. Okay, I squared is minus 1, so this is just minus 1 cubed, which is minus 1. So our solution is just 1 over minus 1, which is minus 1. Okay, so when we're dealing with multiple powers of I, it's all about thinking what power have I actually got going on here. If it's an odd power, there will always be an I remaining. If it's an even power, it's either going to be minus 1 or 1. You just need to learn the difference. Basically, if it's an even power, when you divide it by 2, if it's odd, you're going to get a negative solution. If it's an even number and you divide it by 2 and it's an even number, you're going to get a positive solution, 1. Okay? But those are little tips and tricks rather than the understanding. What about combining our complex numbers? Okay, what happens when we add a complex number? Sorry, I forgot to mention, these are not really complex numbers because there's only the imaginary parts here, or the real parts. So a complex number includes a real part and an imaginary part. Okay, so when we combine our complex numbers, what's going to happen? So when I add z1 and z2, I get 2 plus 3i plus 8 minus I. Well, with addition, you just collect like terms. So the solution to this is just 10 plus 2i. Okay, so addition, as with algebraic addition, just collecting your like terms. Same with subtraction. So when I do 2 plus 3i and I minus, I'm just going to put this in brackets, 8 minus I, because I'm minusing all of 8 minus I, so I've got to remember what's going to happen with my double negative. 2 minus 8 becomes minus 6, plus 3i minus minus I becomes plus 4i. Okay, so addition and subtraction, just collect like terms. Okay, when it comes to multiplication, and I'm doing 2 plus 3i times, in fact I'm not going to put times in there, I'm just going to do double brackets, 8 minus I. Well, we expand our double brackets in the same way we do with algebra as well. So I'm going to expand out brackets. 2 times 8 is 16. 2 times minus I is minus 2i. 3i times 8 is plus 24i. And plus 3i times minus I is minus 3i squared. So 3i squared, well, I squared is minus 1. So minus 3 lots of minus 1 becomes positive 3. This becomes 16 plus 22i plus 3, which is 19 plus 22i. So we're now going to have a look at this question here, which is z1 times z1 with an asterisk next to it. So what is z1 with an asterisk? Well, whenever we have the asterisk, what it refers to is the conjugate. Okay, so we can say that if z is equal to x plus iy or yi, then the conjugate is x minus iy. So all it means is times it by the same thing, but the imaginary becomes negative, or the opposite to what it currently is. So this would be 2 plus 3i times 2 minus 3i. Okay. When we expand this, 2 times 2 is 4. We got 2 times minus 3i, which is minus 6i. We got 3i times 2, which is plus 6i. And we got positive 3i times negative 3i, which is minus 9i squared. Well, minus 6i plus 6i will just cancel out. I squared is minus 1, so minus 9 becomes positive 9. So this just becomes 4 plus 9, which is 13. Okay? So just knowing that this situation here is the complex number and it's what we call its conjugate. Hopefully I've spelled that right. No, I did not spell that right. Conjugate. There we go. Don't know why I spelled it with a C. Now let's have a look at division. So we're going to do Z2 divided by Z1. So Z2 is 8 minus I, and we're going to divide it by 2 plus 3i. Well, this is quite, well, you can't do anything at the moment with this. We need to know what we can do to basically rationalize our denominator. So when we say rationalize our denominator, that means get it into just a number, basically. We just want the bottom to be a number. Well, a number that can be expressed as a over b. Okay. So we need to get rid of 2 plus 3i. Well, let's think about what we did in the last question with its conjugate. What happened when you multiplied a complex number by its conjugate? Well, it made it become a rational number. So when I multiplied 2 plus 3i by 2 minus 3i, we got just 13. So to deal with a division, what you're going to do is multiply the top and the bottom by the conjugate of a denominator. So this becomes 8 minus I times 2 minus 3i over 2 plus 3i times 2 minus 3i. So multiplying back to conjugate. I know the bottom from the previous question is just going to become 13. So it's really just working out the top now. So 8 times 2 is 16. 8 times minus 3i minus 24i. Minus I times 2 minus 2i. Minus I times minus 3i is positive 3i squared. All over 13. And then it's simplifying this down. Positive 3i squared, I squared is minus 1, so it becomes minus 3, so we get 13 minus 24i minus 2i minus 26i all over 13, which simplified down is just 1 minus 2i. Okay, so a few things to take from this lesson. What is I? I is the root of minus 1. Our root of minus 1 is I. How can we deal with root of other numbers? Well, breaking it down into its imaginary part and its real part to write as a single thing. What can we do with things involving I, where we've got squaring of i's, add, and the like? Knowing the power laws. How do you add? Well, you just add them. Subtract, just subtract them. Multiply, treat it like an algebraic expansion, and then just deal with the fact that you get an I squareds at times, or things with i's that cancel out. Conjugate, z value, if the z is x plus iy, the conjugate is x minus iy, just from the negative of the imaginary part. And for division, you need to use a conjugate by multiply by the conjugate. Multiply top and bottom by conjugate. Hey, still confused why I spelled with a C earlier. Makes no sense. Okay. Hopefully you followed along with that and you've picked it up and can have got some questions now to do with basic complex numbers and basic uses of I. So thank you for watching and I'll speak to you again soon.